Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem that is the UTF-8 validation. So this is a medium level question, and we'll understand how this question can be solved. And we need to understand a lot on this question because this may create a huge amount of confusion in anyone. So this is a tricky question basically. So we'll understand that one step by step. So before moving on, if you haven't subscribed to the channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. Let's understand what the question says. The question says we are given an array called data that is representing the data. So that's the data array we have over here. Fine. And we need to return whether it is the UTF-8 encoding, like it translates the sequence. Uh, of like valid UTF-8 encoding characters. Okay, so we need to return whether it is a valid UTF-8 encoding or not. Okay, so that's our target. Now, whenever we are given this question, the first thing that comes in our mind is like, what is this? What is this UTF-8 encoding? So, and how, like, what are the rules basically to encode anything in UTF-8, right? So, the first thing the rules that they mentioned to us is like a character in UTF-8 can be like 1 to 4 bytes long. Remember, this is most important. Okay, like this is an important stuff that like help you to stop getting extra, like few of the test cases may run false if you don't remember this condition. Okay, so that's an important thing. So a character in UTF-8 can only be 1 to 4 bytes long. Okay, so see, like it can max be 4 bytes long, are not less than one, not greater than four also. Okay, then they're subject to the following rules. Number one, the 1 byte character, a fast byte is zero. For like 1 byte character, the fast byte is zero. Like the first bit is zero followed by the Unicode code. So if it's a 1 byte character, the number of bytes is one. So in that case, the first bit you can say is zero. Okay, the first bit is zero and followed by Unicode code. So this X, like denotes a bit of binary form. Okay, so either zero or one. So this X is not what we are looking for, but we are actually looking for the first one means, well, if the number of bytes, okay, number of bytes is one, that means the first bit will be zero. If number of bytes is two, like for n byte character, the first n bits are all ones. Okay, and the n plus one bit is zero followed by n minus one byte, uh, with the most significant bit being 10. What does that mean? See, if it's a 2 byte character, the first two bits, like the one and one, is like are all ones. Okay, if it's a 3 byte character, the first three bits are all one and one. Okay, and then followed by n plus one bit as zero. Fine, and then the exact sequence carries on, and then for the next bits we find it's like is simply 10. It starts with 10. Okay, so that's the UTF encoding. Like if there are 3 bytes, so there's like the first bit being the first one, then the second one, and the third one. So you see, the for all the following in minus one bit, we find that it's like the most significant bit, most significant 2 bits are 10. So that's what you see. For four, it's like the first 4 bits are one followed by a zero, and for the next n minus one bits, n minus one bytes, we see that it's like 10, 10, and 10. Okay, so this is the rule for us. Okay, now if we just look at an example we have, okay, the example they gave is 197, 130, and 0. Fine. So if 197, 130, and 0 are given as an example to us, it says true. Why? The true being, it says like in this, the 197 is represented by this. Okay, and then 130 is represented by this. Fine, and then 1 is represented by this. Exactly, this is what it is. So if we look at 197, we see the first two bits are 1, right? We see the first two bits are 1 followed by a 0. Fine. We see this is the sequence. So once we find this, we know this is a 2 byte character. Fine. So this becomes our, like, 197 becomes our first byte, and then 130 becomes our second byte character. Fine. So in that case, we see like this is a first byte and this is second byte. So if this is a first byte, so here you will see it starts with 10. Yes, it starts with 10. So that's the UTF-8. So this is a 2 byte character that we find, and then followed by we find there's another character left. So this is the 1 byte character. Why? It starts with 0. Right? It starts with 0 and it's a 1 byte character. So it follows all the rules, and we find that this is, yes, this is a true. This is true. This is the UTF-8 encoding is there, and then there's a number like 235, 140, and 4. So for 235, you see a number like this. Fine. And for 140, you see a number like this. And for 4, this is a binary representation of 4. Right. Now, in this, what exactly happening? So in 235, you see like there are 3 ones, right? 1, 1, and 1, followed by a 0. So that means there will be uh, uh, 2 more numbers with 10 preceding, right? So here you find the first number with 10 in the beginning. So that's the first one. And from the second one, when you find here, you find this is not 10, right? This is not 10 that we are looking for. If this is not a 10 that we are looking for, then it's clear that this is not an UTF-8 encoding. Okay, so this is like incorrect and we written false. Fine. So all we need to check is pretty much the fast bits only. Okay, it's pretty much the most significant bits only. Now there's one more important aspect remains over here. Like what if our value is like whenever we are only going for this kind of a UTF-8 octet sequence. Okay, so in that you see there's like only 8 bits are there, right? Like I mean, there's only 8 bits are there. Like any of the sequence, you find this 8 bit. Like whenever you are going for 130, you see that it is get contained in 8 bits. Okay, that's right. But our UTF-8 is not confined to only 8 bits, right? What if our value is something like say a bigger value, 476. What I am trying to like explain over here is like in 8 bits, what's the maximum value can we incorporate? So maximum value we can put in this 8 bits is like 255, right? 255 is the maximum value that can be displayed in this 8 bits with this 0 1 combination. So what if our given data value is greater than is greater than this? Okay, so whatever our ith value is greater than this. Okay, so what will happen? So in that case, something is given to us in our node. Okay, so this is important. This is simple. Like for input, like input is an array of integers. Okay, for only the least significant 8 bits of each integer is used to store the data. Fine. Only the least significant 8 bits. So if it's more than 255, say it's more than 255, some number is getting up, so we are not bothered about that number. Okay, we are not bothered about that bigger, like all the most significant bits. We are only bothered about the least significant 8 bits. Okay, so that's it makes clear. So whatever we are seeing this kind of pattern, whatever pattern we are seeing, so it's like it's the least significant 8 bits are only we are keeping in our consideration. We're not bothered what's like before that, right? So that's the idea over here. So it makes us clear about this. Okay, so like which means each integer represents only 1 byte of data. So that's the idea being given to us. So that's a node. And now once we have understood what the stuff we need to do, let's try to understand how we can code this actually. Okay, how we can actually find a solution in terms of coding. Now you might have remember that there's a concept in like whenever this bits are being considered, then it's better to go with a bit manipulation. It becomes faster. Okay, it's obviously it becomes faster. Now in bit manipulation, there you will remember there is a concept called right shift. Okay, so what it does, say there's a number like this. Okay, like a bit number is like 1000 as a binary number is there. Okay, so once you do right shift like 1000 right shift 2, so what will happen? So once we do this operation, so this will be like in 2 places from the top, it will move. Okay, it's 2 places, all the numbers will move to the right. So that will be like 0 0 1 0, right? So if it moves 2 places, we are sure, like, we know how it works. Okay, this is the right shift operator. So in this question also, we'll use our right shift operator. Okay, so first thing we'll try to do, we'll get each of the data from our array, fine, and then simply first thing we'll try to do a right shift of 7. So actually 7 means these are the 7 uh, uh, characters we don't need. We just need the first character, fine. We'll right shift first 7, fine, and check if it is 0 or not. If it is 0, then we know that this is a single bit character, there's nothing remaining to it. Okay, like, it's not followed by something, so we are not worried. For if the other case, if see, in the next cases, if it is 2, then there are like 5 characters. Say, check over here, there are 5 characters. So the next case, in next if case, we will do a right shift of 5. And if this 110 is what we find, that means, if 110 is what we find, that simply means it is our like a 2 byte character, like 2 byte numbers are there. So it should be remaining, like the next 1 bit should be there. So we will have another variable that is the remaining, and it will store that one other variable are there. And in that variable, we will not check for these conditions. We'll simply check whether it starts with 10 or not. Fine. Then for the 3 bits, like 3 bytes, we will go for 110. So that how we'll do that, we'll simply do a right shift based on 4. See, so this is the 4 bits, right? For 3, there are like 4 bits we don't need. We need the first 4 bits, right? So that's the right shift 4. Then 4 bytes, we will do a right shift 3. Okay, so that's what all those values, all those bits is not important to us. We're just simply right shifting them to find our important bits we are looking for. Fine. So we'll right shift it by 3, and then we'll put a remainder as how many? 3. Fine. And here we'll put a remainder as 2. So this is the idea. Now, once our, like, initially we'll put remainder as 0. So if our remainder is 0, we will continue this loop. Okay. If our remainder is not 0, then what we'll right shift by 6 units. Why 6 units? There are like 6 units. Okay, like while our remainder is not true, remainder is not 0, we'll keep right shifting 6 units, and we'll check if it is something like 10 we're looking for, if the first 2 bits are 10 or not. Okay, and if that is so, we'll decrement our remainder. If it is not that case, we'll simply return false. Fine. And in our remainder 0 case, if our remainder is 0, if we don't find it falling in any of the cases, we'll return false. Fine. And simply the other case will be at the end of the code, we again need to keep a check that if a remainder is 0, then if you return true, else return false. So that's the idea. Okay, so it's like a true false, like if else case, but the idea is only get easier whenever you are doing a right shift operator. Okay, so let me quickly write this code, so I hope you can understand what the kind of code we are going to write. So let me quickly write this, and then I will explain to you again on how we can visualize this part. Okay, so let's me quickly write that. Okay, so this is pretty fast solution. I don't know why all of a sudden it went with 8 ms, but I will resubmit it later. Let's see what exactly we're doing. We're taking each of the, like, items in our data, that is I in data, and we're checking for the remaining. Okay, now what we're doing, if our remaining is 0, that means we don't have any further checks remaining. Okay, so if our remaining is 0, we're simply checking for which byte it is. It's like if it's we'll like write shift 7 and we find, if you don't know the 0b followed by some number, then I should tell you, like whenever we write something like this, like 0 then b then some number. Okay, so that simply means it's a binary form, like we're looking for the binary form, because like when followed by say 110, that means we are making sure that this 110 is not integer, but rather it's a binary of the number that we are looking. Okay, so that's how we represent binary. Because if you are in other formats, we do something like 0 8. So whenever we do 0 8, it means like we are in octave format. Okay, now we can do 0 1 6. So those are also can be possible. So that's the stuff we do. So whenever we like 0b in the beginning and followed by some numbers, so that means this 110 is a binary form of the number that we are writing right now. Okay, so 110 is in binary. So that's basically it means by that. Now let's understand it. The question, like how, what we did, we need like if I, like we write shift I by 7 bits, so that write shift I would result is in this. And if it's like 0 be 0, so that's if it's 0, then it's like remaining is 0. So we know it's like 1 byte number. Okay, then we, if that's not the case, we write shift by 5. So that's write shift 5 is like this one. uh, if it's like equals 110, that's the initial 110, we know that it has one number remaining. It is like remaining basically means if there is other remaining numbers. Similarly, we do for right shift 4 numbers. Right shift 4 numbers would result as in 1 1 1 and 0. Okay, so that means this 1110 is like a third byte number. Fine. So that means simply means we will have two more remaining numbers. Fine. Then we have right shift of 3 bits, and that's like right shift 3 bits results as in 1 1 1 1 0. Right. So that's what we did, and we're checking for like the remaining is like 3, because like 1 2 and 3, these are the three remaining should be there. And if all these cases doesn't get valid, like if either any of the case is not true, that means this number is not within this 1 to 4 bytes long, that means simply will return false. It's false for us. Fine. Again, like if the remaining is not 0, then we'll check for other conditions. Like what are the other conditions when the remaining is not 0? That is like if one like we simply right shift this number by 6 by 6y. So this is the six values we have to ignore, and the first two values is what we are looking for. We right shift it by 6 and it should be 10. If it's 10, we simply do a remaining minus minus, like decrement our remaining. And in that, like else, if this is not the case, we find as in our example 2, we don't find over here the 10, so we simply returns a false. Right, so we simply return a false out here. Fine. Now, once we have moved through the whole, the whole data array, okay, and we, if our remaining is 0 and we didn't find anything, like if it may happen the last value is a two byte number or 4 byte number, so that remains whether remaining is 0 or not. So if our remaining is 0 at the end also, we'll return it as true, and else we'll return it as false. So once we have checked like all the numbers, we should return true, right? So that's the condition over here. So this is how this question works, and it's a pretty fast question solution. But all of a sudden, I don't know why it is trying to show as a 8 ms. See, like I resubmitted, it went down to 2 ms. Earlier, when I resubmitted, it went down to 1 ms. So this may happen, right? This may happen with this LeetCode judge. Anyways, so this is the idea of this question, and that's how you can actually solve this question. So I hope the question is clear to you. And this one important idea is like OB. As I said, it used to represent the binary numbers. Like whatever followed by OB is like in binary form you are writing. Okay. So I hope it's understandable. If you have any doubts or any question, make sure to comment them down. I'll be happy to help you out in the comments as well. If you're looking for its complexity, complexity is simply order of n. Order of n in the meaning is just referring to this data array, right? That's order of n. And in terms of order space complexity is we are using only one additional space. that's a remaining integer, right? That's the what it is stored. So that's order of one, remaining integer, right? So that's how you can actually solve this. Make sure to like this video and subscribe to this channel for regular LeetCode videos like this. And thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.